Hey there everyone, welcome to the series Automate the Boring Stuff in Ansys Mechanical. In today's video, we will be looking at bold pretension. To add bold pretension, it is as simple as getting into analysis and just calling add bold pretension. But purpose of this video is to automate the entire process. For example, you might have tens to hundreds of bolts and you want to uh, add pretension for individual bolts or the cylindrical surfaces of the bolt and add pretension to it. We will automate that entire process. I have this coupling model which has 6 bolts, 6 nuts. I have already simplified the model, and if you look closely you will see that I have already splitted the surface so that automatic contact generation is simple. Let's say if I hide this body, you will see that I have this bolt. Let's hide both the bodies. You will see that I have already split the face. Now there are two ways to create bolt pretension. I have seen some people who applies bolt pretension to the bolt body itself. So what they do is they select the body, create a coordinate system, and for that we have to ensure that axis of the bolt is equal to z axis. It has to be, and then they applied the bolt pretension because bolt pretension is applied on z axis. The other way to do that is you split the surface and apply pretension to this face directly. What Ansys will do is it will split the surface into half. I mean mathematically, and it will apply exactly at the center and in the axis of the surface. Now it is also important that you cannot have mm, two cylindrical split surfaces. It has to be one. If you have two, then choose any one. So right now I have this, and if you see, I have also splitted this bottom surface so that the only the portion of the bolt surface which is in contact with nut surface has bonded contact. So we will see both the process, how to loop over all the surfaces. Right now I will keep the flange body hidden, and then we will see how to loop through uh, all the bodies and find out which is bolt surface, which is cylindrical in surface, and then we will put a logic to add that surface id into a list, and then we will use this list to create a name selection, and from name selection we will generate uh, bolt pretension. So there are two approaches. First one I said to go through all the faces, and the second one is go through all the bodies. Okay, so yeah, that is two method of adding pretension. But again, to reach when we go through the option where we apply bold pretension to the faces, again there are two methods. One is to reach this face, there are two methods. One is through going through this geometry bodies parts, or you can use of geodata. So first we will see how to use geodata. Okay, so let's start with geometry, and we need to read geodata. For that you can just call ext api dot data model dot geodata. So I will call this as geodata. So I have the geodata body. Now geodata will have assemblies, and then parts. Under parts you will have bodies. Under bodies you will have faces, edges, or surfaces. So I know that my geometry has only one assembly, which is geometry. So I can just call geodata dot assemblies. You will see I have only one assembly wrapper, so I will call this 0, and then all parts. So you will see these are all the parts that I have this. Now it is important that first you will have part name, and then you will have uh, the body name. Okay, so the part name is bold and body is solid, so it's not part, I mean I don't have multi-body part, so everything is one-to-one mapping. So from here what I can do is I let's get the name of all the bodies. So I will create a list comprehension. I will just type pass n dot name for part in this one. Okay, so just to get the name so that I get the index, and we will do and then loop. Okay, so this has to be part. Okay, so I have flange, bolt, and then nut and nut. So let's work with bolt first, and then we will see how to get that um, in logic. So for first, let's get this index 3. So I will just parts is equal to parts, and then let me just capture bolt inside an variable which is parts, and then I can pass the index 0 1 2. So I will have bolt dot name. Yes, bolt. I have bolt uh, bolt object stored in bolt variable. So from here, uh, bolt, I will have bodies. Okay, bolt dot bodies. You will see that each part is having one body. So I have this part bolt, and then uh, body which is the same part. So here again I can loop it, or I will just say body bolt body is equal to bolt of first index. Okay, sorry, this should be bolt dot bodies of 0. I have the bolt body. Now bolt body will have several faces. Okay, you see there are so many faces in it, and to find out this surface, this type of this surface is uh, cylindrical, right? So let's see what are the surfaces a bolt has. Okay, so same we will use list comprehension. So what we can do is face dot the function method name is surface type. Okay, so it will be for face in bolt body dot faces. So what this is doing is I am looping through all the faces and storing in variable face, and for that face I am calling surface type. What should be the surface type? You will see I have cylinder, a plane is 2, I think this top 2. Okay, and then I have uh, face cylinder as 1 2 2 cylinder, 3 cylinder. So 1 2 3 4, there should be 4. 1 2 3, 3 cylinder is coming. 1 2 3. Okay, sorry, this is the entire. I thought this was split. And then we have 2 planes, so this is correct. Now if you want area of it, so you can just call, instead of surface type, you can call area, or and then you can call radius as well. Radius will come only for cylindrical surfaces. So let's capture any one, let's say the first index. Okay, so just for test is equal to faces 0. I have not stored faces anywhere, so it will be bolt body dot faces. Okay, test is face wrapper, test dot, I have area. Okay, let's see if radius is there. Radius is also there. Okay, so here instead of area, if I pass radius, then for plane surfaces this might give error. Okay, so you see selected surface is neither cylindrical or spherical. So wherever you had this surface plane, it is giving error. So what you can do is you can pass if the uh, surface type is cylinder, then only give me the radius, but let's not get into that. Now I know that this radius are size 10 millimeter. Wherever you are getting 0.01, right, you have two surfaces, so this is 10 millimeter, and this one is 16 mm. So I don't want the 16 mm part face, I just want the 10 mm face. But in 10 mm itself I have two. Then what is the other way to do that? So maybe a height or the surface area. Let's see if test has any height. Okay, height is not there. So only thing is we have to go through the area method. So who, and the other one area is uh, this one 1946 millimeter square somewhere, and this one is 2762.35 millimeter square. So we will make use of this bigger surface and loop through all the faces and store the IDs of these faces. So I should get 6 IDs. Okay, So here creating a loop will not be feasible. So I will do it at the top. Let me clear this window and go back on the top. Now I already have geodata. Let's see if that variable is available here or not. Geodata is working fine. Then we have mm, parts. Part size is also working. So those variables are already available here. So just to show you, let me type again ext api dot data model dot geodata. Okay, and then parts is equal to geodata dot assemblies first index, and then I will got all parts. Okay, now I will have to loop through all the parts. So it is for part in parts. Now as you know, this are the part and this is the body. So these are not multi-body parts, and then I have to put a logic in such a way that this loop consider only the bolt of sizes that I need. So you have to put that in a logic. Since I have only one size bolt, so you will see these are bolt. But if you have multi size bolts in your model, it can be of various numerous sizes. So make sure that your modeling team is sending you bolts with a proper naming convention. For example, this should be bolt M10, bolt M16. That it should come in that way. So for right now, since I have bolt, so I will just get use the parts only whose name is bolt. So if um, part dot name is equal to bolt, it is case sensitive, so you have to make sure it works correctly. And then if I get the part, then I will go through the body. So for body in part dot bodies. Okay, now I am inside the body, and then inside body I have to loop through faces. So it will be for face in body dot faces. It is capital body dot faces. Now since we saw that these faces are of numerous type, then I need to work only on cylindrical surfaces. So what I will do is I will again put a if statement telling if face dot surface type is equal to then we had geo, I think I had test, right? Test. So test dot surface type geo surface cylinder. If you think carefully, this geo surface cylinder, whatever you're getting, is actually enum property. So how can you evaluate with a string property? So it should be dot to string, so that you can compare a string, and then this will also convert the type into a string. So if face name is this, and then now cylindrical surfaces are 3, so I need to use only whose area is something like uh, this should be in millimeters. So in remember in ACT all the units are millimeter. So here this is the surface area. I need to use this surface area. Okay, so here what I will do, and face dot area is equal to this number. Okay, so this might not work. So what I have to do is 0.00276, and if I put test dot area, you will see I am getting a very long number, so I have to round it up. This is very important because if you don't round, then it will not match. So let me round it to 5 digit. Okay, so round test dot area to 3. So this is the function name. So 3 digit is not working, sorry, not 3 but 5 decimal. Okay, so this and this value, whatever I got and whatever I am checking are same. So this value, it's not hard, you should not hard code it. Maybe based on the board sizes for which you are doing the loop, right? You need to create a formula and create this area out of that. So this one I will use it. So instead of face dot area, will pass round. Okay, and if it is working, then I will store the ID something is wrong. Okay, Now let me make it smaller. Okay, and once I get this face, I have to store the ID of this into some list. So what I will do is, here I will create a empty list called as uh, bolt bolt faces. Okay, I will create an empty list here, and then I will append the list with bold faces dot append, and here what I am getting, face dot id, face dot id. Okay, and then I will come out of the loop and I will try to print it and see how many faces it got. Okay, let me run it. Let me clear this out and run. So you see I got several faces, but this is not correct because I should get only 6 surfaces, right? 1 2 3 4 5 6 6, but I am getting several surfaces. Let's see what are the surfaces it is choosing. So I need selection info to select it. So cell info is equal to ext api dot data model, not data model, selection manager dot new selection. Okay, and this, from this, not new selection, I have to create selection info, and then from here selection type is geometry entities. Okay, so once I do that, and cell info I have to append it. So cell info dot ids is equal to my bold faces, and then I will try to uh, highlight it. So it will be uh, create selection or new selection, and I will pass cell info. Let me run and see what are the faces that it is choosing and why it is coming incorrect. If I run it, you will notice that, okay, the area is coming. Okay, so this is the mistake I did. So this should not be test.area, it should be face.area. Okay, let's run it again. Okay, so now you see all the 6 surfaces are created. I already have these faces stored in uh, in a list. Now I need to assign it to a variable name selection. So what you can do is, here I already have cell info, right? So what I can do is uh, name selection, right? Uh, it is in model dot name selections dot add name selection dot location is equal to cell info. Let's see if it is able to do or not. So this selection, this is working correct. So what we will do is, instead of directly creating this selection info, what we can do is we can create a generic function, and then generic function to name selection, and then do that. Let's see how it goes. So definition, created function, create create name selection, and we will pass the list. So it will be what we can call face IDs or location list, and then we will pass a name. Okay, here what we will do is, first we will create this inside this selection info. Our selection info is already created, so we don't have to pass this again. So we have to do cell info dot id is equal to this location list, and then name, right? Name selection, add name selection. So it will be ns is equal to this, ns dot name is equal to this name, and then ns dot location is equal to the cell info. Okay, so this is function. Let's not use this anymore, this is not required, and we will call this function now. Create name selection, and then pass the list of the location, which is bold faces, and we will pass a name telling us called as ns underscore bold faces. Let me delete it. Let me run it. Okay, so it is working fine. You see these 6 faces are created. This is working good. So this was one method. Now instead of going through the geodata, let's go through the bodies. I will use the same function here. So instead of geo, I don't want this to. Okay, let me comment it out. So instead of that, what will happen is I need to go through geometry. So let's call it geo dot geometry, and then let me get parts, all the parts. So it will be geom dot parts. I think it's children. So all the children will be right, and check what it is giving. Parts, right? Okay, so this is working good. Now we will loop through all the parts. Okay, so same thing, if part in parts. Okay, part dot name is bold, and here instead of part dot bodies I will have to go through the children. Okay, part dot children, and then I have to get the geo body of it. So geo body of this body, so it will be for geo body is equal to body dot get geo body. Okay, so I have this geo body. Now instead of body, wherever body is there, I have to change it to geo body. So for face and rest everything will work. Let's see if it is able to create. This is method 2, so I will pass the name as underscore 2 and let me run it. Okay, so this is not working. Let's see, bold faces is empty, so why it is not working? So I have this geobody dot faces face dot type bold faces. Okay, let me comment it out and see what is the bold face first. Bold face is coming as empty list. Something is wrong. Let's get geobody dot faces. Let me see if it is getting inside this print face dot surface type. Okay, so it is not getting inside the loop. Let's see if part dot name is wrong or something. So this way you can troubleshoot. I did directly. That's why part dot name. Okay, so it is not getting inside this as well. I think something is wrong. Let's see geom dot children. This is okay. I have this part. Let's see what part is giving. Part is correct. So part dot children. This is also correct. I think part name is coming something as wrong. So let's find the names of all the parts. Okay. So this part, right? So it will be x dot name for x in geom dot children. If I run it, okay, so it is coming as bold bodies. So this is, you have to be careful. That's why. So let me do this. Delete all this. Now print is no more required, and let's see if it is giving something. Okay, so now it is working fine, and I will uncomment this name selection and run it again. So you will see ns boldface 2 is created. This was the old one. So this is also working good. Okay, now we will create all the bold pretension based on this name selection. Okay, so let's, I have this name selection ns, I believe. Okay, ns is not working, so I can pick any one of the name selection for testing here, and then we will write the script in total. So what I will do, ns dot it is model dot named selections, and then first index. Named selections, name selections dot children 0. Yeah, this should work. Okay, I have this name selection, which is first one. Let's check the name as well. Okay, so this is working good. So what I need to do is from here, this for each of the list I have to create bold pretension. Let's create a dummy pretension for now. So it will be analysis. Okay, I have this analysis 0. So model dot analysis first one. Okay, a0 dot bold pretension, add bold pretension. So instead of that, what I will do is, this is a selection info, right? So I need to loop through IDs and create this selection info dot ID. So here what I can do, for location in, okay, what we can do is we can create bold pretension inside this loop itself. Okay, no need to create one more loop, but that's fine. So let me just capture this and then run later. Okay, first index, or get children by name also, I think it's possible. Let's see if it is working or not. Children, get children recurses type, filtered by type. No, this will not work for us. Okay, no problem, we will take here it's ns. Okay, so for here, for location in ns dot location, print location. Let's see what it is giving. Let me comment this create name selection so that I don't create again and again. Print location. Okay, I'm getting the location IDs. This is good. And here I have to create bold pretension, right? Here let me assign this a0. So it will be a0 dot add bold pretension. Okay, it will return a pretension model bold bp. And then here, so what are the things that you get when you create a bold pretension? So what we can go and just click on just to add a bold pretension. So we have this geometry, right? So it has to be a selection info. So what we can do is same thing, cell info dot IDs is equal to list, and then I have this location. Location was integers, right? All these numbers. Cell info dot IDs, and then bp dot location. bp dot location is equal to cell info. Okay, let's run it. Yes, cool, it is working. One was already there. Let me delete and recreate. If I run it, okay, great, it is working. So what we can do, instead of bold pretension, we can define some numbers at the end. Okay, I think it's creating it again and again. Maybe I did not delete it correctly. Let's say it should create 6. Okay, yeah, so bold pretension is working correct. Okay, now the second method is throw bodies. From body we have to uh, create coordinate system, and from coordinate system uh, we can add a name selection. I mean, we will create coordinate system and bold pretension together. So this was the first approach, which had two methods inside it. One is through looping through geodata, or looping through bodies. Let me clear this. Let's not clear it. Let me go to the new script, clear this. So now what I have to do is, now I have to loop through all the bodies and then uh, create a coordinate system. So coordinate system is already aligned with z-axis, so I don't have to re-rotate it. So here I have this part name, so I can copy this. I just have to capture the bodies. Okay, so it will be bold. Instead of faces, I will call it bold bodies. Okay, so for body in part called children, bold bodies dot append body. So I can print this, print bold body, see if it is giving the bodies or not. Okay, so this is wrong, so it should not be body, it should be body.id. Okay, it should be body. Something is wrong. Body, I have a part and then body, then I should get bolt.id. Bolt object does not has id, so body dot get geobody. Okay, so this body id is actually the id of this object, but it should not be this object, right? It should be from the selection manager, or the, sorry, not from selection manager, or yeah, selection manager or the body. So I should get this. Let's print. Okay, so I'm getting 5 bodies, and just to ensure that the bodies selected are correct, what I will do, ext API, sorry, I have cell info, right? Cell info dot ids is equal to bolt bodies, and then from here I will call ext API dot selection manager dot new selection cell info. Let's see if it is highlighting it correctly or not. Okay, so this is correct. So now inside this, maybe what I can do is, instead of creating multiple function, or even creating bold bodies, I don't have to do that. Here itself I can create a coordinate system, right? So here model dot, what I can do is cs is equal to model dot uh, coordinate system dot add coordinate system for that body. So it will be cs dot origin location. It's not location, it's origin location, and then I can just simply pass this id. Okay, let's see if it is working or not. Okay, something is wrong. Expected I selection info got int. So again, this selection info should be inside. So what I can do, cell info dot id is equal to this id, and then pass the selection. Let me delete this which was created. If I look, let's see if it is correct or not. Okay, so this is correct. These are created correctly. So instead of, let me delete it again, because within, I will use the same coordinate system within the loop itself. Now I will add the bold pretension. So here, here, right, I can copy this. Sorry, I can copy this, go to script 2 and paste it here. Shift tab is not working, tab is working. Okay, so what are the things I need to do? Here name selection I'm creating. Okay, fine. ns.name, I will comment it out. Then ns.location is cell info, correct? And then if I use the body, then I have to send let's test it out. I add a bold pretension. If I select a body, then I have to create a coordinate system for it. So coordinate system is ns dot coordinate system. It's not ns. No, I'm doing wrong. I don't have to create name selection again. If you want, you can store it, but Right now I need to do directly bold pretension. Okay, so bold pretension location is I can use cell info instead of this location. No, I don't have to use this at all. bp dot location. Now bp dot add, not add, coordinate system is equal to cs. Okay, so what it is doing, I am going through all the bodies. In the body, create the coordinate system and use the same coordinate system to uh, to use it in bold pretension. Okay, so first I am creating a coordinate system. I am assigning the location of the coordinate system with the bold, and then I am creating a bold pretension, and immediately after creating I am assigning the body also, which is in selection info, and also assign the coordinate system which I just created there. Okay, so this is one way. So let me delete all this and run this again. So you see coordinate system, bold pretension, coordinate system, bold pretension. Okay, so everything is created, bodies are highlighted. So this is working correct. Okay, now after doing this, okay, so now automating the creation of bold pretension for multiple boards is done. Now let's choose any one bold pretension, and from bold pretension let's see how we can load the data, how we can lock it, and what the various methods available. Okay, so let me get object by name for this bold pretension. Okay, so it will be ext api dot data model dot get object by name. Okay, and then I will rename, copy. So here I have to pass a string name. Okay, let's see what it is returning. It is returning a list of all the objects whose name is bold pretension. So one I mean I can have different bold pretension with same name also, but object IDs are different internally, so it does not matter if you have duplicate names or not. So I need to access the first index, and then I will assign it to bp. Okay, now I have this bold pretension object with me, and let's go one by one. What are the things we have? Location is already set, body is already set, no need to do anything. Now we need to check how to define by whether it's load, adjustment, open, or lock. Okay, so how it works. Now there are two properties which we use. bp dot get defined by, it says get the bold defined by value at the given solution step. So right now I have only step 1. Okay, so let's do one thing. Let me make it step 2. Okay, I go back to bold pretension and define by, and then pass 1. It is telling load. Okay, if I pass 2, it is also load. Now for this one I want to define a preload. So what I can do is, instead of get defined by, it will be set defined by, and then it is telling I have to pass a integer which is step number, and then bold defined by of type. So this is the column. Now 1 comma, I'll just copy, pass dot, no, I need to load. So this is already there, it won't change. I'm just showing how to set it. Load is set, but for second load step I want to lock it, because first step we always load and second we lock with the pretension. If I do 2, you will see this is locked. Earlier it was load, now it is locked. Now I have to set preload, right? So since we were working on define by, now we will be working with preload. So it will be bp dot preload. You see you are getting 0 and 0. So I need now the same logic, multi-load step logic. We have to pass this, right? We have to pass the discrete values. So it will be preload dot inputs first index, because we always get list in nested list, dot discrete values. You will say I'm getting for 1 second and 2 seconds. Now I have to define for uh, first second with some load. Okay, so it will be, instead of output, let me use out instead of input, let me use output, and then I can pass a quantity. I have this copied here. Okay, so 10 newton, 0 newton. 0 newton is for the lock, but it does not matter, it's already locked. So even if you give 10, right, it won't use it. So if I pass it, you will see 10 has been given. Similarly, you have some pre-adjustments in millimeter or length unit, so it will be bp dot pre-adjustment. Okay, similarly you have increment. So based on these things, you can just change the value. For example, here itself inside the loop I was creating, right? So what I can do is I can just uh, pass these values. So first load step I want to lock. Okay, second load, first load step I want to load, second is lock, and then I will pass this preload output as 10 newton. This will be parameterized, you have to put it inside a logic. So let me delete all this and let's see if it is able to do now. So let's run it. Okay, coordinate system were already there, it is creating again. Okay, let's see. We have a load, lock, 10 newton, everywhere it's same. Now there is one more thing you can do. You need to group it, right? So the good way to group things are to group immediately after creation. So let's say you have two bolt sizes and you are running the loop two times or calling this bolt pretension script. So if you call the grouping at the end, what it will do is it will put all the pretension irrespective of sizes of bolt into one folder. So what I recommend is after running this loop immediately, mm, for example here I have a bolt bodies of M10 size. So once this is done, straight here just below this line, once this loop is done of the bolt bodies, and before entering the next loop, you can just group it. So what you can do is, we are in static structural, right? A0. So A0 dot group, A0 dot group all similar children. Okay, group all similar children. Yes, correct. So what will happen is if you run the loop two times, everything will not go inside the single uh, folder. So I think we can also name the folder. It does not return anything, but we can access the folder name and then rename it. For now, let me run this again. Coordinate system created, ball pretension created, and then it will look. It will also group it. Okay. So this was all about bold pretension and how you can automate it. I hope this video will be very useful. Please subscribe and like this video. Thank you.